Okay, so for today, we're going to discuss about the complex numbers and the complex variables. So first, let's define first what is complex numbers. So complex numbers are numbers of the form a plus bi, where a and b are real numbers and I is the imaginary unit. And it is also defined as the square root of -1. And then the standard form for the complex numbers is z is equal to a plus bi. And then in complex numbers, we have basic operations being used, which is the addition, subtraction, multiplication, and the division. So in subtraction, all you have to do is you just have to add the real parts separately and then the imaginary parts separately. So for example, we have this. So we have 3 plus 4i plus 2 minus I. So you just have to separate the real parts, which is 3 and 2, and then the imaginary part, which is the 4i and then the negative I. So do the math. We have 3 plus 2 here. 3 plus 2 is 5. 4i minus I. Then here we have an imaginary number of 1. So 4i minus I is equal to 3i. So we have 5 plus 3i as our final answer. Next, we have the subtraction. So you just have to subtract the real parts separately and the imaginary parts separately. So it's the same with the addition. It's the same process, but all you have to do is to subtract. Of course, it's subtraction. So 3 plus 4i minus 2 minus I. And then do the math. 3 minus I is 1. And then 4, it became positive, by the way, guys, no? Since negative times negative, it will become positive. So we have positive I here. So 4i plus I, we will have 5i. So I plus 5i is our final answer. And then next we have the multiplication. So in multiplication, use the distributive property and the fact that I squared is equal to -1 to expand. And then also you can use, by the way, FOIL method for this one, since FOIL method is also easy to use. By the way, it's property, yeah, it's not proper. It's property, I'm so sorry. It's a typo. And then next we have the division. So in division, you just have to multiply the numerator and the denominator by the complex conjugate of the denominator. Then simplify. And then if we're going to say conjugate, so conjugate is changing the sign between two terms. So for example, we have this. So we have 3 plus 4i. So the conjugate of 3 plus 4i is 3 minus 4i. So all you have to do is whatever value whatever operation is being put in here, you just have to get the reciprocal. Like for example, a positive, so the opposite of this one is negative. So we have 3 minus 4i. So that's the conjugate. So next we have the complex variables. So complex variables are variables that can take on complex values. So they are often used in complex analysis. It is a branch of mathematics that studies the functions of complex numbers. So example, we have f of z is equal to z squared plus 2x plus 1, where z here is a complex variable. And then next we have g of z is equal to e raised to z, where z also here is a complex variable. And then also in complex number, we have different forms. The first is the rectangular form, trigonometric form, followed by polar form, and the exponential form. So in rectangular form, we have z is equal to a plus bi, where a and b are real number and I is our imaginary unit. So in trigonometric, we have z is equal to r times cosine theta plus I sin theta, or you can write this as z is equal to r cis theta, where b is equal to r sin theta and a is r cosine theta. R is equal to modulus, which is equal to a squared, square root of a squared plus b squared. So if you're going to find the value for the modulus, you just have to square root the value of b and then the a. So it's like finding the magnitude of the number. And then theta, of course, it's an angle. And then for polar form, we have z is equal to r angle theta. So we have here an argand plane or a complex plane. So in y-axis for the argand plane, it is where the imaginary parts located or the imaginary number is. And then in x-axis for an argand plane, it is where the real numbers are being found. And then exponential form, we have z is equal to r e raised to I theta. Since z is equal to this, equal to r times cosine theta plus I sin theta, and since e raised to, it is being raised, guys, I'm sorry for the typo. E raised to I theta is equal to cosine theta plus I sin theta. So we therefore obtain another way in which to denote a complex number. And then next we have successive integral powers of I. So it is said here that any integral power of I is I or -1 or 1. So we have I here, which is equal to square root of -1, or I. And the next we have I squared, which is equal to negative 1. And the next we have I cubed, which is equal to I squared times I, which is equal to negative 1 times I, which is equal to negative I. So here we have a value, we have a rule for multiplication that if you're going to multiply a number that has an exponent, all you have to do is just to add the exponent. So here we have imaginary number 1 here, so you just have to add the 2 and the 1, so we can have 3. So 2 plus 1 is equal to 3, that's why we have I cubed. And since I squared is equal to negative 1, so we have negative 1 here, and I will remain as is, so it's I. So negative 1 times I, so it is negative I. And then next we have I raised to 4. So the same process with this I cubed. So you just have to simplify this one and then add exponent. So we have 2 plus 2. We have 4. So 2 plus 2 is 4. And then I squared is equal to negative 1. So I squared is negative 1. So we have negative and negative here. And then in multiplication, if you are going to multiply two negative number, you can obtain a positive value. So that is why we have positive 1. So I raised to 4 is equal to positive 1. And then we also have some examples here, by the way, class. So find the complex number of 9 plus di plus 4 minus 5i. So it is an addition operation, no? Just do the math. Just add this one, 9 plus 4, and then add 7 plus negative 5i. So you can have a final answer of 13 plus 2i. So next we have here the same problem with this one, but it's in a subtraction form. So subtraction operation. So 9 plus 7i minus 4 minus 5i. We have 5 plus 2i as our final answer. 5 plus 12i. Sorry. So next we have this multiplication or a product. So 9 plus 7i times 4 minus 5i. If you are going to use FOIL method on this one, you can come up with a solution and then do the math. You can actually obtain a final answer of 1 minus 27i. And then next we have the division. So find the complex number of 3 plus 4i over 8 minus 2i. So I said earlier that if you are the process for the division in a complex number, you just have to multiply the numerator and the denominator and the conjugate of the denominator. So since it is 8 minus 2i, so the conjugate of this one is 8 plus 2i. So as you can see in this part. So and then they use FOIL method, no? And then combine like terms, cash out since it's positive and negative and it's a same like terms or like terms. And then the value for I squared is negative 1. So we have negative 1 here. And then do the math. We can come up with the answer of 16 plus 38i over 68. And then simplify. We can have 16 over 68. Then it's the same denominator plus 38 over 68i. And then it is, you can reduce actually this one. It is divisible. So you can have a final answer of 4 over 17 plus 19 over 34i. And then if you are looking for some examples, so we have assessment here, we have three problems here, and we also have answer key for your guide. So I hope you understand something from me and see you on the next session of this video. God bless.